Okay, so till the previous video, we have learned how to name a particular coordination compound, and also we learned what is the coordination number of the central metal atom in a coordination compound, or the oxidation number of the central metal atom in a coordination compound. So before starting this next video, I I expect that you have the methods in mind how to find out the oxidation number and the coordination number, because the coordination number part will be used in this video extensively. Okay, so we'll move on with the next part of the topic. So in this topic we will basically talk about a term related to the coordination compounds. It is called coordination polyhedra. Now what is coordination polyhedra? Like, everything has a shape or a particular structure of its own, every compound. In a similar manner, these coordination compounds have a particular structure which is known as polyhedra. Okay, now there are three different types of structures which are most common in use, and they are also in the JEE syllabus as well as the board syllabus. They are present in the NCERT, written in the NCERT also. Those three are octahedral, square planar, and tetrahedral. Now we'll move on with basically what it is and how is it uh, written, or whatever is its notation. So firstly we'll keep this in mind that the ligand, this Lx, Ly, L dash y, this is how a coordination compound ka coordination sphere or the coordination entity is represented inside the square braces. We know that. So this is the central metal, these two are the ligands. Okay, and so moving on. So what is coordination polyhedra? The spatial arrangement of the ligand atoms. Okay, the spatial arrangement of the ligand atoms which are directly attached to the central atom, metal atom, or the ion defines a coordination polyhedra. That is clear, I guess. It is defined about the central metal atom. Okay, so now we know how to find the coordination number of a particular compound, of a particular central metal atom in a coordination compound. So for that I guess you know this method. Let me show you that we had this method in which we had to sigma the number of ligand I into denticity of that ligand I. Say for this example, if we can find out the coordination number of this Ni, nickel, so H2O has denticity 1, Cl has denticity 1, only we will consider the ligands. Okay, H2 has denticity 1, Cl has denticity 1, coordination number for nickel, number of H2O 3 into its denticity 1, number of chlorine 3 into its denticity 1, add them up 6. Similarly, in this example, if we see H2O denticity 1, En denticity 2, you can refer to the table also which was given in the previous video. So denticity of coordination number for nickel over here 2, this 2 number of H2O into its denticity 1 plus 2 into denticity of En 2, add them up, it will come out to be 6. Here it is how the coordination number is found. So say for a particular compound we find out the coordination number to be 4 or 6, then these two coordination numbers have a particular shape or a structure. Okay, so coordination number 4 has two structures related to it or associated with it. Those two are tetrahedral and square planar, and coordination number 6 has a shape related or a structure related to it which is named as octahedral. So in a particular coordination compound, if you find out the coordination number and it comes out to be 4, then you can say that the compound is either tetrahedral or a square planar compound. And if the coordination number comes out to be a 6, it is an octahedral compound. Now this question might come in your mind, that how will you differentiate between tetrahedral and square planar? That if we study VBT, which we'll study in the next topic, in the next video, valence bond theory, we'll learn how to separate these two. These two have different hybridizations basically, so that is how they are differentiated. You'll learn how. Okay, so we'll move on. So these three are the shapes in particular. Octahedral means coordination number 6, which means that there are 6 bonds. Okay, there are 6 bonds. Always deal in terms of the number of bonds, okay, not in the number of ligands. Like over here you might see there are 6 ligands only, so you might feel that coordination number is 6 because 6 ligands are attached, but let me tell you that even this structure has a coordination number of 6. One second. Even this structure has a coordination number of 6. You will ask how, right? Because what is En? You know, why I'm asking you to deal in terms of the number of bonds, because coordination number does not specify the number of ligands attached to the central metal atom. It specifies the number of bonds formed with the central metal atom. Okay, so there might be different number of ligands, but the coordination number might be different from the number of ligands. Like चूँकि यहाँ पे these ligands are monodentate or unidentate ligands, these ligands are forming one bond only. Each ligand is forming one bond with the central metal atom. So the coordination number and the number of ligands are same over here. But in this case, this ligand forms 2 bonds. This is a didentate or a bidentate ligand. You know that. So this ligand, each ligand forms 2 bonds with the central metal atom. So if we see that each ligand is forming 2 bonds, so only 3 ligands are there, but the coordination number will turn out to be 6. We can also verify this mathematically. Say this M is over here. If we find out the coordination, this can be written like this: MEN whole 3, right? And if we find out the coordination number of M over here, we know 3, the number of En, into denticity 2. There's no more ligand, so nothing more to add. It will turn out to be 6. So this is also an octahedral structure, although it is having only 3 ligands. So that one thing you have to keep in mind, that you cannot tell the coordination number of a particular central metal atom by just looking at the number of ligands in that compound. You need to find out the coordination number, or you need to count the number of bonds formed total. Okay, because sometimes each ligand forms 2 bonds in case of didentate, some ligands form 3 bonds, tridentate ligands, some form more than that also. Now moving on to the next type, these two are tetrahedral and square planar structures. These are related to the coordination number 4. Okay, now these ligands which are drawn over here, these are also monodentate ligands. Now if we, so here the coordination number as well as the number of ligands are same, but if we take the example of any other, say we take this only, En only, say MEN2 only we take, then this MEN2 will also have a coordination number of 4, although it is having only 2 ligands, because denticity of En is 2. Each En forms 2 bonds. So total number of bonds will be 2 into 2, that will be 4. So that's why you have to find out the coordination number that way. Okay, and once you have found out the coordination number to be 4, अभी तुमको निकालने का नीड नहीं है how to differentiate between tetrahedral and square planar. You will learn that in the valence bond theory part. Okay, now further I will be explaining you how these 3 structures look like. Okay, so what is the meaning of these? Okay, so how do they look like? Let me explain you. See, let's take the case of this octahedral. Okay, octahedral, I am explaining for this structure only. Okay, let's take the case of this octahedral. Then in case of octahedral, this is, say this is a plane. Okay, this is a plane over here. Here the central metal atom is placed on the plane. On the plane a central metal atom is placed. Then one ligand is ऊपर की तरफ, one ligand is नीचे की तरफ. Okay, one ligand is पीछे, one ligand is आगे, one ligand is ऐसे, one ligand is ऐसे. This is how the octahedral structure looks like. Okay, 4 on the plane, 2 ऊपर नीचे, 6 total for monodentate. Now for square planar we'll learn what a square planar structure looks like. Take the example of any book. Take this plane. Okay, here is the central metal atom. Say here is the central metal atom. If we take this position as the central metal atom place, then four ligands will be, if the 4 ligands are monodentate, then they all 4 are in the plane of the notebook. 1, 2, 3, 4. This is how a square planar structure looks like. Now what is a tetrahedral structure? Tetrahedral structure, you know how it looks like. It is one central metal atom, two like this, and one outward, one inward. You know what a tetrahedral structure looks like, right? And you have learned that in the chapter chemical bonding also. What is tetrahedral structure? Similar, tetrahedral is same, okay,